Well, g'day guys, welcome to the channel and welcome to my next little project. Isn't he lovely? Okay, let's have a look at him. Here we go. Aurelia International. I don't really know much about this radio at all. No doubt we'll look into some specs and we'll put them on the screen for you. External antenna, car antenna. Can't show you much about it. On-off volume. Stations. Medium wave, long wave. We're going to do something a little bit different this time. This is one nice little radio, a little transistor radio, and I promised you a transistor radio. After my last couple of valve ones, I'm a little bit over them. So let's do a transistor. Now apparently I do have some information on this. We've got to remove these somehow. I will get my sheets on this and we'll have a look at exactly what this thing is. Now, I won't put them up on the screen. I'll grab a sheet of paper and stick it in front of the camera for you. Long wave, medium wave. The switches are pretty hard. I don't want to push them too much without lubricating them. The station's working okay. Don't know whether that's a dial cord or gears. I think it's gearing. And, well, we've got France and we've got Luxembourg and we've got Finland and all sorts of, funny little places in here. We've got Brussels, Italy, there's Budapest. There's a lot of interesting little stations. So where does this come from? Let's have a look. Now then, guys, well, this little radio, according to Radio Museum, it's a French radio. Now, there's some specifications on it. I know this is not the best way. I should be putting all this up on the screen properly, shouldn't I? As from the PDF. But yeah, anyway, here it is now. Now it says 6 transistors up there, where are we? Up the top up here. But it's got a whole heap of listing of transistors, so I don't quite know what all that's about. Okay, broadcast and long wave. It's a 4.5 volt system, so guess what? We can put one maybe 18650 in there and make it rechargeable, and well, 4.2, I reckon it'd run okay on 4.2 volts. So we can maybe do that modification with it. I'm not going to Bluetooth it or anything like that. I want this to remain pretty well intact. There's the other bits and pieces on it. Yeah, it's a plastic case. It's got a little speaker, a 3.5 inch speaker. Shape, well, it says very small portable. Yeah, well, that says a lot. And yeah, there's the rest of the notes on it. So, not a lot about it, really. It weighs 800 grams. And it's probably without the battery. Okay, so that's that bit, and well, here we go. Here's our circuit. It's a Tomore, I guess, and there we go. We'll probably have some caps in here that we've got to change. Just looking around. there's an electro here, and it seems to have replaced that one, and well, that transistor. Oh no, it's pointing over here to a resistor, 47 ohm resistor, and a 1 ohm resistor. I dare say check them, but maybe that's a fault when the output stage goes up in smoke or something. But I think they're the only two electrolytic caps in this whole thing. TR1, okay, up here it's a BF 233, a 255, or a 184 for that fella. T2 is a BF 321, a BF 254, or a BF 195. T3, same with T3, so they're both the same. T4, and he's over here. That's our actual audio driver. Now it says a BC 208, BC 148, BC 108. Very common transistors for this. T4 and 5, well, you nearly guessed these, being germanium PNPs, AC 184, AC 117, or an AC 132. So there you go. It's a very generic type layout. And up here, well, there's your rod antenna, switching between long wave and medium wave. I don't know which is which there. It's got PO down that way and GO down that way. Not real sure about that. So obviously oscillator here, and it looks all fairly straight. No, hang on. This is actually a 3-stage IF. No, 2-stage. That's a bit of a strange arrangement with this here being the converter mixer. Yeah, anyway, we'll get in and let's have a look at it. Now, how do we get into it? Do these come off? Not real sure, guys. This case comes apart. Do these pop out? They don't seem to want to. Okay, we've got a battery holder here. There we go. So old school 4.5 volt cell. There it is there. And I reckon, well, I'm not sure. We could probably fit an 18650 in there, can we? Ooh, we might be able to. Yeah, maybe need a bit of modification, but I could probably put an 18650 in there. There would have to be a mod done on that to make that fit. And if that was in there, I've space in here to fit a small charging board and a USB-C socket on it for charging. Be a very handy way of doing that. So not much written on that. Okay, that hasn't allowed us to get into it. Do these come out? No. The sides come off. Does this? No. They're loose. How does this work? They do come out. They do. Okay, so that one comes up, and I'm guessing by the look of that. That's what they are. I don't want to break these. But I think we're going to need a little bit of help here. Okay, well, yeah, that definitely has to come out. And there we go. We're up. Now this will probably come out this end as well. I'm not real sure. Okay. Yeah, well, something's happening, but the top doesn't. There we go. Okay. Oh, guys, look at this. How nice is this? That's a really nice egg slicer, isn't it? That is really nice. Wow. And yes, there is a dial cord there. It almost looks like a fishing line. In fact, looks very much like fishing line. That is a work of art. Okay. One electro there, one electro up in there. That's it. Some little poly fellas, a filter here, ceramic filter, 2 IFs, obviously that's the oscillator coil. No, this will be the oscillator, sorry. So, what is it, 3 IF? Or something for long wave or something. No, it'll be an IF because way down in there, there's a detector diode. Okay. 2 output transistors. So this is our front end oscillator. First tranny, second tranny. Back around up here to audio driver transformer. Output transistors, output transformer. And an aerial socket for car radio or external aerial. Okay. This is an exciting little radio, this. Ow. How did the other side come off? Because this side doesn't want to. But it has to. It's got the speaker on him. Does he? How does it come off? There we go. It just hangs in the top with a little rail along the top there. Yeah, a bit dirty there. Okay, now this side. Here's our speaker, quite a chunky little speaker. Very nice little speaker. And here's the other side. That's our rubber band there that's very, very hard. And our long wave and medium wave coils on our rod, the back of our egg slicer. What a beautiful little set. And those wires, oh boy, they're hard. They're solid core wires and yeah, very, very hard indeed. Okay. And as for the stations, if you look in there, there's a dial cord arrangement from hell in there. I wouldn't like to be doing too much with that. Yeah. Righto, guys. Well, what are we going to do? Well, we better start it up, I think. Now, I'm going to, before I damage anything else, I'm going to remove the speaker wires, and I'll just put a couple of alligator clips, a couple of extension clips on the speaker, so that yeah, we can sort of work with it a little bit. These wires are very, very hard. Okay. Let's take these off. And, well, we don't know whether this speaker works or not, but we'll soon find out. And, well, I want to clean the case up here, so the speaker will be coming out of here. Be interesting to see the other side of this speaker. No markings on it. And this one, well, the other side we'll be cleaning up there, and, well, the rest of it, I'm not taking all this apart, that's for sure, especially this bit that involves a dial cord. So we'll be just cleaning this up from the outside and then working out how we're going to fit an 18650 battery in there. There's plenty of room up the top here to extend. You can no longer get these batteries anyway. It's not 2Ds or anything like that. This is 4 volts. So, yeah, okay. We'll have a look at that as we go along. Let's get a couple of jumper leads and put on the speaker and get my 4.5 volts on the power supply. See what happens. Put a couple of jumper cables on. In actual fact, I don't really know what the, unless I missed it, what the IF frequency is on this thing either. I don't know whether we're doing an alignment on it yet or not. There we go. Speakers on. Now, positive and negative. So can we probably go in the back of, yeah, we can get in here and we can go in the back here. Righto guys, got the power supply over here. We're on this one, 4.5 volts at 50 milliamps. We're turned off at the moment. Power supply is on. Let's turn him on, see what happens. Oh. Yeah. Well, it's making the right noises. Actually don't seem to have any stations. Oh.
Yeah, luck you reckon. All right. Cameron, I'm glad you called from Wollongong. Thank you very much for that.
Well, guys, it's
I'm jealous. I've hit the flag twice. I've never got a hold.
all sorts of interference, all sorts of rubbish coming through there. Well, it is picking up stations amongst a lot of other rubbish. I'll turn the light off. Ah, there we go. It's one of my lights. We're going to have to do something with those lights too. Okay. Okay. I think we've heard enough. Okay, we know it works. Yes, there's a heaps and heaps and heaps of interference, which is typical of this shed. And yes, especially on this light. Okay. We're going to do something with this light. Maybe the next video we're going to convert it from the stupid little switch mode supply in it to a linear supply. I think, what's it running on? I think it's 17 volts or something. So we're going to make up a linear supply and just get rid of the rubbishy switching noise out of it. Okay. Turn this off. Now, my first port of call will be replacing especially that little blue fella in there. And, well, of course we'll do this. And we'll measure him and see what he's like. There we go. And, well, as you can see, it's even written in there what it is on the board. Positive end up this end. Okay, here he is. Let's put him on the tester and see what he reads. I don't think he'd be real good after this period of time. Okay, here we go. What are we looking at? 10. ESR 0.5 and a VLOS of 2.3. Well, he's better than what I thought he'd be. Let's get a new one. Okay, here we go. Brand newie. We'll see what he reads. There we go. That's looking better. 10.45. ASR 1.2. 0.6% VLOS. Yep. That's the one that's going in. Spread his wings out a little bit to match, roughly. Negative that way. And just spread him apart there a little bit so he doesn't fall out when I'm trying to solder him in. Now I've got another little wire there. I think it's probably a ground wire to the tuning cap, and put him on. Okay. Right. Can't really notice him in there, can you? Right, this one. Well, I'll show you this bit. 330 mic. He doesn't look too bad. We'll check him out. See what he reads. $546. Pretty high. ASR 0.1. VLOS of 2.5. 546. Obviously leaky. So yeah, glad we're replacing this one anyway. Okay, 330 mic. Now the voltage rating on all these is 10 volts. I'm probably putting in a 16 volt, simply because that's what I've got. Okay, but in this case, I've just gone and got him. He's a 25 volter, 330 mic. Okay, and of course I don't have a radial cap on an axial cap. I've only got radial. So in around there and in around, what do you reckon? About there? I reckon that's about right. I was out a little bit. Not too bad. Righto. Just bend him a little bit there to keep him in. Where can I solder him there? That's better. Okay, I'm not expecting a huge increase in performance or anything with this. The noise level is still there with the lights and everything, but maybe that first one, the decoupling cap there, will make a little bit of difference. Okay, well guys, let's turn him back on and see, is there a difference? And then I will also show you something else that I've discovered when I've been mucking around with him. And it's something I don't want to do, and it's connected to the front. There's a hint for you. What do we got? I forget. It's positive over here. Negative on this side. All is ready. Let's turn him on.
From a power system point of view, the very worst location for a power station
Now,
in the country.
I do have my overhead light turned off, simply because of the rubbish coming in through it.
The alternative, which is
And yeah, long wave. Let's see. What's there? Shouldn't be anything. Nothing at all. Not much use with us. Well, these switches are dirty, so we're going to have to give them a bit of a clean up. Going to have to find the IF frequency of this. I'm not sure of it yet. Our little pot needs a bit of a clean, a bit of squirt of contact cleaner. Now, the other thing I've noticed is on the dial, when the needle goes right down towards the end here, you can see it at the front there, it actually it jams before the gang is actually fully closed, and then it wants to jam. Oh, that's not too bad there now. It was probably my imagination. No, it seems to be okay. Comes up here, goes right to the top. That seems okay. It's probably me being paranoid about dial cords. Now, this little pulley here seems to be wanting to go forward as though something's not keeping him in line. If I wind this, he goes forward and wants to fall off. Yeah, there's something not right there. Because this one doesn't do it. This one doesn't. Oh, yes, it does. Yeah, it looks like they just sit there. Okay. Is this me looking for something? I hope not. What's my life come to? Now, yeah. Yeah, now that's not right. That goes down there, and it ends there. But our gang is still open, and I can still... And that's the gang fully, or almost fully open, but not quite. I can wind it further. So is this needle. Anyway, tell you what, guys, what I'm going to do here. These little pins, and there's one at the back, I'm going to take that off in there. Now, I should be able to push this one up or pull him up from this side. Take the knobs off and the handle off, and this front panel comes off, and then we can see what the dial is doing. Something's not right there. It's over scanning sort of thing, but yeah, no, there's something not right. Let's I'll pull this off. Let's have a look and see what we can find. It's not the actual dial cord itself, it's just something else is catching or not working properly there. Okay, now what I'm doing here, very carefully, raising the centre, and it comes off like that, and then this fella comes out. Right, and we can see what it looks like when he comes out. And he's out. For better or for worse, take out. Okay, 2 screws here. Knobs. Obviously they pull off. And yeah, that one does. This one doesn't want to, but oh boy, he really doesn't want to come off. Okay, Can we do anything? Okay guys, we've got this knob off. This took a fair bit of pulling off. Simple reason, it's someone has glued the damn thing on there. But yeah, there's nicer ways of keeping those knobs on other than gluing like that. Okay, we'll, after that shell shock of getting that off, let's have a look at this dial string. This here doesn't look right, because when this goes from one end to the other, I will put our knob on here. It hits these fellas, and that's what's happening. And now that's just worse because that fella come off. Something's not right with the dial string, for sure. I'll just put this back on while we're mucking around with it. Okay. This doesn't seem to be in the right position somehow. Because as it goes to either end, we'll take him back up to this end, and hopefully these little wheels, you can see that it hits this fella as well. That is not right. It should ride down there. Yeah, okay. And then this is all in the wrong place. Oh, okay. Let's have a think about how this thing should work. But it's how it is there now. That is certainly not right. And I'd also like to keep those little fellas on there. I might, yeah, no, I won't do anything with them. And it's a very simple arrangement. Okay, I'll come back to this. I'll try and work out what's going on here. Okay, well, what we've found is this needle was actually down in there, running along the other side of this. That is supposed to be on top of this little bar here, which makes it level this way because the height of the pulleys is above, the height of the string is above a few millimeters there, and when it runs on this bar, the pointer is actually level. Okay, so now if I can keep these fellas on here, I'll do it like this. He runs fine to that end and no worries to that end. It's not catching on these fellas, which it does if it sits down inside here. Now I don't know whether it's I don't know how it's got in there, but that seems to work absolutely perfect there. That's fully closed, and we go up the other end, fully open. Okay, that's that problem fixed. The next problem we've got, well, getting this apart. Our little pins actually broke for the handle because they're so brittle that they just, well, break in half. There they are there. So we'll probably just put a nice little chrome screw in there. I'd rather that on the handle than some brittle, tiny little plastic pieces. Okay, and the other thing, someone's tried to glue this switch on instead of maybe just building it up a little bit, or yeah, we're going to have to do something with that. So otherwise, there's the problem with our tuning. That's fixed up. We'll give this a little bit of a clean up inside now. I'll do what I've just clean it up. We'll clean this thing up. It needs a bit of a polish. It's not real good. And we'll work out what we're going to do with our battery. Are we going to put in an 18650? Are we going to put in an 18650 with a just a tag, not a tagged 18650, not one with a in a holder like what I showed you initially. This is in a holder. This battery, a tagged 18650, will go in there, no problem at all. I do have some little charger modules. We'll fix one of those and work out. Well, I also have a USB-C sockets that we can wire up and possibly, well, put in the back here somewhere. I don't want to modify this a lot, but without a 4 volt battery, this is not going to happen. And I want this thing to be, as good as possible. Hope you've caught all that. I've got a habit of not looking at my monitor. Okay, we'll go ahead, do all this thing, and I'll be back. I'll show you bits and pieces of what I do. Okay guys, well, we've got the front on, looking nice. Now our station pointer, dial pointer, is running nicely, end to end, and if you can see in there, you probably can't, but it's running right to the end of our little track there, right there, and he goes right up the top to the end of the track there, and you can see, possibly see in there, just right to the end. So all that's right. We've, well, secured our volume on-off switch a little bit better than what it was, and at least you can take this off. That was just a little bit of paper to build it up and make it tight. Okay, so now I'm going to do the rest of the case. I'm going to remove the speaker here. We're going to give this a bit of a clean up and polish. Now these little nuts, obviously, I'm not real sure of these, how these are done, whether they're press fit or screw fit or what they are, but they're coming off anyway. Looks like they're threaded onto the plastic. Yep, that's all it is, just a little nut that's threaded onto a plastic post. And I'm going to put a very small mark in here so that I know the terminals of the speaker are up that end. Okay, And there we go. And yeah, I was right. There is a little bit of dirt and fluff in behind this one. We'll clean that up and certainly clean this up. I'm going to probably give these a bit of a tub, a bit of soapy water, and give them a bit of a scrub to get all the rubbish out. We'll give it a polish and just bring it up just that little bit nicer than what it is. Okay, so there's our speaker. A very unusual type speaker for this. And as you can see, this is what's falling out of it. Certainly needed taking apart anyway and cleaning up. But very nice speaker. And this will have great sound once I get it away from my lights here in the workshop. Well, guys, not my lucky day. I just went to grab a brush to clean this, and the magnet fell off the back of it. It's the magnet seems to be only held on there with the paint. That's all that holds it on. And yeah, that's a matter of can I get this thing back together, but I don't know. I don't know how. I think another speaker will be the only way of doing this. I don't know what ohmage this is. I'll just obviously this will give us a DC reading, not a frequency reading. Let's see what it reads. What are we? $20 ohm. This is a bit of a worry. That's a 20 ohm speaker. Well, that's what it's reading. And of course there's nothing written here. And this speaker taps off the transformer. So we're going to have to simulate a 20 ohm speaker. And here it says it's a dynamic loudspeaker, moving coil, 3.5 inch. Doesn't say anything about it. Oh dear. So, can we fix it? I don't know how we'd get this all back together in the right position. Yeah, doesn't look like it's ever been glued, and I'd say this paint has just given way. It's also a little bit rusty just around the inside of it there, which probably hasn't helped things. So, guys, what do? We can remove our dust cap. We can put our back cover back on, glued, and the magnet then in from the front. We can do that. Actually, there's a little bit of insulation coming off there, but that's probably not a problem. Now, this fella, get that off. That looks like that's been glued at some stage as well onto the magnet. And, well, surrounded this, you can see it's the only thing was holding it, I think, was this little piece here. All the rest is rusty around the sides. So it's a matter of, can we put this thing together again? Gee, this is yeah, unexpected with this little radio. So many things unexpected. Okay, there's our magnet. It's a matter of, can we put this back on there? Like so. Yeah, there certainly wasn't hardly anything holding this together. That's about where it was. It just fell off. And as you can see, a little bit of the cone in the centre, the voice core former, is starting to come away. I'm going to have a look at that under the Maggie lamp. We may be able to get this thing back together, and then, well, we've got to get the magnet in from the front and see how this works. Well, I can't do much with this little speaker. I can't get it together. There's actually, yeah, a bit of damaged wire on the voice coil. So, and getting this centered with this sort of speaker, yeah, I thought I could put the magnet in from the front, but no, it's just too small to work on. And yeah, I'm going to have to pull out of this little speaker rebuild, which is a shame. It's original and it's very unique, but yeah, with the corrosion around the edge of it, and well, that's basically what holds it on. And the paint, or well, it's not actually paint, it's powder coating. So yeah, it's a shame. Okay, should be able to find a speaker in this lot. What have I got here? Let's these have been packed in here for years and years. It's been a long time since I've been back to them. I can see some round ones. That little fella. Shame he's too small, because that would work. Because it doesn't say on the circuit anything, as you've seen, about it. It's just this arrangement where you've got taps on the transformer. So we're probably looking at, 8 ohms a side or something like that. Yeah, I don't know. If you guys got any ideas down there, let me know of this arrangement. I haven't come across this before. As I said, I'm a repair tech, not a restoration tech. So a lot of this is new ground. Doesn't say anywhere about the speaker. Let me try and investigate a little bit more, have a little bit more of a play here with speakers, and see what we can come up with. Okay, now what I've done, this may look a bit crude, that's me, a bit rough around the edges. I've got 4 little spaces over, these are fibre washers, over the protrusions at the case pegs, or whatever you would call them. Why do I have a memory lapse when I'm on camera? I know off camera what everything's called. As soon as you get on camera, you think, what am I saying? Okay, anyway, you can see what I've done there. What I'm going to do is I'm not going to screw anything. And why are the spaces there? Well, it's because, a couple of reasons here. This speaker I'm using, the actual surround actually comes above, as I showed you earlier, the outside of the metal frame of the speaker, the basket. So yeah, I just wanted to give it a little bit of space there. Yeah, I know it's not airtight and all this. This is a transistor radio that we want to get going. The other thing is I tested the speaker first, works perfectly. I removed the back magnet off this one. What's the purpose of this back magnet? Now, I'm not big on speaker technology or anything. I don't know. Speaker's a speaker to me. So can you guys explain why the second magnet? Because I've put this on with just one magnet and the sound, well, strangely enough, sounds better without the magnet. Okay, now this is an 8 ohm speaker. We're looking for, 20 ohm. What's going in series with this one will be a 12 ohm, or in around there, 10 to 12 ohm wire wound resistor, so that we get the correct loading on the amplifier. Okay, so that's all I'm going to do there. As I said, it's a little transistor radio. It's not a hi-fi piece of gear. So yeah, that's sort of how I'm going to get around it. In here, I'm going to push them all forward as far as I can, and I'm pouring hot glue over each one. Okay, that will never move. So that's the next step. Just hot glue it in, and yeah, I'm pretty sure that speaker will be right forevermore. Okay, let's do it. Rightio, speakers in, ready to connect. Now, what I've done there, guys, is put in another couple of wires. They're a lot softer than these very, very hard wires here. I'm going to take them out and just put these in. Just makes it a little bit better. Now, because the speaker's 8 ohm, I've put a 10 ohm wire wound resistor in series with it. Wire wound because of inductance and so forth. If you don't know about resistors in speaker systems, do a search on that. It's a little bit different to your carbon or metal resistors. A little bit different behaviour. So we've got 18 and actually measures 19.8. The other speaker, DC voltage or DC ohms, the other speaker registered, I think it was 21 or 20.1 or something like that. So this will do the job. The correct loading on, yes, it might be exactly the same output, but the correct loading on the output stage. You don't want it too low on these old girls because, well, probably designed a 20 ohm DC speaker impedance, probably in around 33 ohm when it's running. You don't want to put much of a load on these. They're not designed for it, these germanium transistors. So I've read up on anyway. So here we go. We'll change these, and well, then really we'll probably connect this up, see how this goes. Then it's time to do the battery and charging circuit. So we'll connect this up, give it a test, see if it still works okay, see what it sounds like, and go from there. Okay, got it all hooked up now. The speaker's hooked up, power supply's hooked up. Our volume is turned off. We'll engage our power supply going to here, turn it on. And 16 milliamps, same as before. And of course, yeah, it's
Relaxed.
And how about if I turn the other light off?
First day of a really long holiday, but it
There we
wasn't.
go.
Here I am. The record song.
That sounds $1 million.
And here, something gone wrong around here. Something gone wrong around here.
sounds great, guys.
Something gone wrong around
That's
here.
pulling,
Something gone wrong around.
yeah, about 40 milliamps on its peaks.
Choices at Home is helping the city's
And that's
older
actually
residents get out and about.
peaking out at 50 milliamps. I'll just take that up a little bit just to make sure everything's right. So we go over maybe 60 milliamps. We'll try that.
50 and over for locals of First Nations origin can access this subsidised social service if
Yeah, about
registered
50.
with My Aged Care. To register,
59 milliamps. I'm not real sure what this is supposed to draw, but it's a pretty hefty output stage, so we'll go across 80 mil. Okay.
and overall heart health. PJ100's powerful antioxidants also protect against oxidative stress and inflammation.
Yeah, it's sort of peaking out at 80 mil there. Now, does it say anything on the notes as far as current draw? No, it doesn't. Okay, it doesn't. But
Region for the 7th time. Witness a field of 120 of
I mean, you're not going to have it. You're not going to have it that loud, really. We'll go the 100 milliamp and just see, make sure that 90, 100 mil, and
play on Foxtel and KO from 11 a.m.
yeah,
Kia's most awarded SUV, the 7-seat Kia Sorento. Available in petrol, diesel, hybrid, and
it's a little bit heavy on the
fine-tuned for Australian road.
on the current there. Like that's peaking out at 99 milliamp.
To find out more, visit kia.com.au or visit your nearest Kia dealer.
Kia. Movement.
But only just. That is very, very loud and at full volume. So in around the 100 milliamps. And, well, really, looking at this circuit, yeah, I'd believe that would drag in 100 milliamps for sure. Just the arrangement of the output stage. But anyway, guys, comments down below as well. Get down there and tell me, in that type of circuit, is 100 milliamps acceptable? I think it is, but you may have other ideas on that. And as I said, nothing in here on current draw. Okay, but we do have one little thing on here that we will need. And you see that figure there? IF 480 kilohertz. Okay, so that's our IF frequency, 480. That's what we'll be aligning this to. I didn't see that earlier, so yeah. And of course we all know what that song is. And yeah, must be Love Grows, eh? And we won't play any more of that. Righto, let's get on with the power supply.